Hello friends. Friends, today we will derive and discuss the Coulomb's law from Gauss law. And I have already derived the derivation of Coulomb's law and Gauss law. Okay, so let us start the derivation. So to derive the Coulomb's law or to find the intensity of electric field due to point charge. This is basically one of the applications of Gauss law, that is to find out the electric field intensity due to point charge. And another name of this is, that is the derivation of Coulomb's law from Gauss law. Now to derive the Coulomb's law, we need to have a point charge plus q, and we will derive a Gaussian sphere around it having a radius r. Now all the points on this surface are equivalent, and according to symmetric consideration, electric field intensity E has the same magnitude everywhere. That is because all the points are at a distance r from the center O. Okay, so electric field intensity will be same here, will be same here, will be same here, same here. That is at every point. Therefore, we can take an area element here, a small area element ds, and the direction of the area element will be outward. I have already told you that the direction of area element is always outwards. Okay, it is always outwards. And the direction of the electric field due to this charge will also be along this direction. Electric field, because this is positive charge, and due to positive charges, the electric field intensity, the field lines, these are the directions of the field lines. Okay, so from this small amount of area element, the small amount of flux will be E dot ds. I have already told you about the flux. So this will be equals to, by dot product, EDS cos theta. Now what is the angle between E and ds? Because ds is along this direction, E is along this direction, so angle will be 0 degree. EDS cos of 0 degree. So it will become EDS. Okay, this is the small amount of flux passing through this small area element. Now if we consider the whole of the sphere, okay, then what will be the total flux? The total flux we will get, just integrate d phi. This will be equal to phi. This will be equals to E dot ds. Okay, E dot ds, or this equals to integral of E dot ds. Now what is the integration of ds? This is a sphere. What is the area of sphere? Integral of ds is 4 pi r square. So phi equals to E 4 pi r square. This will be our equation number 1. That is flux through this, total flux through this Gaussian surface due to this charge, positive charge, will be E 4 pi r square. Also from the Gauss law, flux is equals to Q by epsilon naught. Electric flux is equals to Q by epsilon naught. So this is our equation number 2. Now compare equation 1 and equation number 2. So what we will get? We will get E 4 pi r square Q by epsilon naught, or E is equals to Q upon 4 pi epsilon naught r square. So this is electric field Q upon 4 pi epsilon naught r square. Okay, so as F equals to Q naught E. Now, if there is a second point charge, Q naught, be placed at a point at which the magnitude of E is computed. Okay, suppose there is a second point charge Q naught here, which the magnitude of electric field is computed. Then the magnitude of the force acting on the second charge Q naught will be equals to F is equals to Q naught E. Okay, so due to the first charge Q, the force acting on the Q naught will be equals to F is equals to Q naught E. Now, if we put the value of E in equation number in above equation, so F will become Q naught Q 4 pi epsilon naught r square. What is this relation? This is the Coulomb's law. That is Q naught Q upon 4 pi epsilon naught r square. In other words, this is the equation number 3 was the electric field intensity due to point charge, and this is the derivation of Coulomb's law from Gauss law. I hope so you have understood this thing, and if there is any doubt, please share. Thank you.